Welcome to a session on molecular diameter. And before going to this, we will be discussing the assignments given in the previous session, and after that we will enter into this topic of molecular diameter. So, let us move on to the assignments. The first one is a problem, that is, assuming that methane behaves as van der Waals gas, calculate its boil temperature given that A is equal to 0.2283 newtons meter raised to 4 mole raised to minus 2, and B is equal to 4.28 into 10 to the power minus 5 meter cube mole raised to minus 1. Now, these are the datas. A, the value of A is given. The unit is Newton meter raised to 4 mole inverse. The value of B is 4.28 into 10 to the power minus 5 meter cube mole raised to minus 1, and both these are in SI units. So, I choose the value of R as 8.314 joules per Kelvin per mole. See, in the problem they have not mentioned the value of R, and we have to choose wisely the value of R, and the value of R, since these are all in SI units, I have chosen the value of R to be in SI units. Now, substituting the values for the equation, that is TB, that is a boil temperature, is equal to A by RB. A and B are van der Waals constant and R is a universal gas constant. The value of A is given as 0.2283 newtons meter raised to 4 mole raised to minus 2 whole divided by RB. R is 8.314 joules per Kelvin per mole, and B is 4.28 into 10 to the power minus 5 meter cube mole raised to minus 1. Okay. Mole raised to minus 1, mole raised to minus 1 get cancelled. Newtons per meter and joule get cancelled, and meter raised to minus 3 and newtons per meter and joules, they get cancelled. Okay. And finally, K raised to minus 1 goes to the numerator. So, the answer will be in Kelvin. Solving this using a calculator, you will be getting the value as 641.58 Kelvin. Note that in this case, it is the answer goes wrong if the value of R chosen is wrong. Okay. So, next one is another problem. Assuming that carbon dioxide behaves as a van der Waals gas, calculate its boil temperature given that A is equal to 3.59 atmospheres liter square mole raised to minus 2 and B is equal to 0.0427 liter per mole inverse. The value of A and B in the units, just check the units. It is in liters, atmospheres and all those things. So, I will have to choose a value in liter atmospheres per degree per Kelvin per mole. So, that should be 0.0821 liter atmospheres per Kelvin per mole. That is the difference here. Choosing R, you have to be very cautious, otherwise the problem will go wrong. Now, I have taken the data. The value of A, that is from the data, A is equal to 3.59 atmosphere liter square mole raised to minus 2, B is equal to 0.0427 liter per mole inverse, and R is equal to 0.0821 liter atmosphere per Kelvin per mole. Now, we will go for the equation. Equation is that TB is equal to A by RB, where A and B are van der Waals constants, R is a universal gas constant, and these values are given in the data. So, I can take that A is equal to 3.59 atmosphere liter square mole raised to minus 2 whole divided by R is 0.0821 liter atmosphere per Kelvin per mole multiplied by B 0.0427 liter per mole. 2 moles minus 2, this minus 2 get cancelled. Then this liter and this liter square gets cancelled, and here atmosphere and this atmosphere get cancelled. Kelvin raised to minus 2 becomes Kelvin in the numerator, and on solving you get it as 1024.06 Kelvin, and that is the answer for TB. Okay. So, these are the assignments. Now, let us move on to our topic, that is molecular diameter. In this session, we will be dealing with excluded volume of molecules in a gas. We know that the molecules, when they are moving about in a vessel, only those volume excluding the volume of the molecules are available for free movement. So, what is the excluded volume? And it is also known as co-volume, and for 1 mole in van der Waals equation, we represent that to be B, that is for 1 mole, and that is what we have been using for van der Waals equation as a van der Waals constant, which is known as a co-volume, excluded volume. All these names are for the term B. Next is calculation of molecular diameter from van der Waals constant B. The van der Waals constant B, it gives us the size of the molecule. We have already mentioned it in the previous sessions, and now we will be calculating the molecular diameter from van der Waals constant B. Now, let us first see what is excluded volume or co-volume of a molecule in a gas. Now, here these are the 2 gas molecules. This is gas molecule 1, the other one is gas molecule 2. So, 2 gas molecules, their closest approach, and this distance between the 2 centers, that will be equal to, this will be the radius for one molecule up to this point, and from here to this point, this will be the radius of the other gas molecule. Okay. So, this distance, the total distance will be 2r, that is what they have shown in this, and this is also called by another name known as collision diameter sigma. It is also known as a collision diameter sigma. Okay. So, sigma is, that is 2r. Okay. Now, what we are going to do is, see, when this molecule approaches this molecule, it cannot come closer than this. This is the maximum possible approachable limit for this. Now, this is a collision taking place between the 2 molecules. Now, so this diagram is a 2-dimensional picture, but you will have to imagine the molecule to be a 3-dimensional sphere, and this will be another sphere, and they will be having a closest approach distance, and this is known as the distance between them is known as the collision diameter, which is equal to 2r. Okay. Now, a molecule, the closest approach, that is, a molecule cannot further approach after this, this area, that is 2r to this side, 2r to this side, 2r to this side, all these sides. That is, you consider a sphere around a molecule by the radius 2r. Okay. So, this region is known as excluded excluded volume for a two molecules when they collide. Okay, that is, when two molecules collide, this area you cannot approach anywhere from, you can take it from any direction. So, the 2r with a 2r radius, if I consider a sphere, this will be the excluded volume for two molecules to come together. Okay. Now, we all know from mathematics, that is, volume of a sphere is given as 4 pi by 3 r, where r represents the radius. Radius of the sphere. That is from maths. Okay. But here, though this is radius, in r excluded volume, this radius is 2r. This is the radius. This dotted line shows the excluded volume. You consider that to be a sphere and cross section of a sphere. Okay. So, this is the distance 2r for the radius of the sphere, which we consider to be the excluded volume. Okay, substituting that. So, instead of this radius, it will be 2r. So, substituting that, and thus excluded volume will be 4 pi into 2 into r instead of r cube, and solving that, 4 pi by 3, 2 into 2 into 2, 8. That becomes 8 r cube. That is what is written here. So, the excluded volume is 4 pi 8 r cube by 3. I am going to take this 8 out. You get the expression as 8 into, see, 8 is taken out, the rest 4 pi r cube by 3. So, that is written here. Now, 4 pi r cube by 3 is the volume of a molecule, right. This is the volume of a molecule, because we consider the molecules to be sphere, and this represents the volume of that molecule, because we are considering molecules as a sphere, and if r represents the diameter of radius of the molecule, and then the volume of a single molecule is given by the term 4 pi r cube by 3. Now, I can represent it as 8 into volume of a molecule. If volume of the molecule is represented as Vm, which is equal to 4 pi r cube by 3, then I can put this, that is excluded volume is equal to eight into volume of a molecule. Now, this is when I have considered the collision between two molecules, and this excluded volume is for these two molecules. Okay. Now, for a single molecule, for two molecules it is 8 into Vm, for a single molecule it will be half of it, for we can do it as 8 into Vm, 2 molecules, 8 Vm, for one molecule this is half of that, that will be 4 Vm. We have been mentioning this term, that is, it is 4 times the volume of a molecule. See, that is the excluded volume for a molecule. When I consider a single molecule, the excluded volume for that will be 4 into volume of a molecule. Now, that is given here, excluded volume or the co-volume for one molecule. It is not B, it is for a single molecule, which is equal to 4 into Vm, where Vm is the volume of the molecule. So, I will just brief it once more. See, we are considering the two molecules of closest approach, and we are going to find out, see, this is a collision. So, for these two molecules, if these two molecules, you can keep this molecule over here, you can keep it on this side, any side, top of it, bottom of it, anywhere. This is the distance for between the centers when two molecules are at the closest approach, and that is known as collision diameter, and the distance is 2r. Okay. We know that volume of a sphere is 4 pi r cube by 3 or 4 by 3 pi r cube, where r forms the radius of the sphere. Here radius of the sphere is 2r, and for this excluded volume, okay, I am going to, this is for 2 molecules and I am going to find out the excluded volume. I am taking the radius to r cube and substituting, you will get it as 4 by 3 pi 8 r cube, or it can be considered as 8 into taking 8 out, it becomes 4 by 3 pi r cube, which is the volume of a single molecule. So, 8 times volume of a single molecule, and when we consider that for a single, this is for 2 molecules, the volume involving 2 molecules, and therefore, for a single molecule it will be 4 into, that is half of it, 4 into volume of a molecule, and excluded volume or co-volume for one molecule is equal to 4 into Vm, where Vm is the volume of a single molecule. Now, we are going to calculate the molecular diameter from van der Waals constants. Okay. The excluded volume or co-volume for one molecule is equal to 4 into Vm. Okay. The excluded volume for 1 mole means which contains Avogadro number of molecules. Oh, sorry, this is Avogadro number. 1 mole means N0, that is Avogadro number of molecules. For one molecule it is 4m. For N0, that is a Avogadro number, that is 6.022 into 10 to the power 23. 6.022 into 10 to the power 23 molecules, it is multiplying it with N0, and this is the value of B which we used for van der Waals constant. And van der Waals constant, when I told about the significance of van der Waals constant, it is believed that it is 4 times the volume of 1 mole of molecules, 4 into Vm into N0. Vm into N0 represents volume for 1 mole of molecules. Okay. Now, we have got an expression, that is B is equal to 4 into Vm into N0. Okay. Now, Vm will be equal to, taking this to the other side, B divided by 4 N0. Okay. That is the expression. Let this be the equation number 1. Now, this is Vm means volume of a single molecule. Mentioned it just previously, I have mentioned it. Vm is the volume of a single molecule, and this Vm we can write it in another way, that is equal to 4 by 3 pi r cube, where r stands for the radius of the molecule. Okay. So, r stands for the radius of the molecule. So, this is also volume of a single molecule. Okay. This is also volume of a single molecule. Now, I am going to express the radius in terms of collision diameter. We know that collision diameter is equal to 2r. Just we will go back to the picture to make it clear. See, this is the distance, excluded volume, and that is also known as the collision diameter sigma. Okay. So, we can put it as collision diameter sigma is equal to 2r. Okay. So, Vm we can substitute that as 4 by 3 pi. Instead of r, I am going to take it as, that is r cube. means here R will be equal to sigma by 2. So, R will be here sigma by 2 whole cube. So, that will be 4 by 3 pi sigma cube, 2 2s are 4, 4 2s are 8, right. 8. This 4 and 8 get cancelled, it comes 2. So, 2 into 3 becomes 6. So, that will be 1 by 6 pi sigma cube. So, this is another expression in terms of collision diameter. This is also for a single molecule. So, you can have two expressions, that is V m is equal to B by 4 n 0, and here we have V m is equal to 1 by 6 pi sigma cube, that is in terms of collision diameter. So, I can equate these two, that is B by 4 n 0 is equal to 1 by 6 pi sigma cube. See, B by 4 n 0 is equal to 1 by 6 pi sigma cube. This is equation 2. So, I am equating those two equations, and from that what I am going to do is I am going to derive for the collision diameter or the diameter of a molecule. Sigma is equal to, sigma cube is equal to, I am writing it here, taking the other to the other side, we will have 6b, it goes to the numerator. Now, pi comes to the denominator, 4 pi n 0. Again I can cancel these two, this becomes 3 and this becomes 2. So, that is equal to 3 by 2 B pi n 0. This is cube root of sigma. The molecular diameter sigma is equal to cube root of 3 by 2, numerator we have B, denominator pi n naught or n 0. This is written as cube root raised to the power 1 by 3. So, this gives us an idea of molecular diameter, because sigma means, I will go back to the picture, sigma is 2r, 2r means 2 radius. That is, if you take a single molecule, this is also one r, this is also another r. So, this can be taken as sigma, or that is the molecular diameter. Since it is 2r. Okay. Now, we have a problem based on it. Calculate the molecular diameter of nitrogen given that B is equal to 0.0391 decimeter cube mole raised to minus 1. B is equal to, the data is given, the equation is sigma is equal to 3B 3 into 0.0391 decimeter cube mole raised to minus 1 whole divided by 2 into 3.14 into 6.022 into 10 to the power 23 whole raised to the cube root of this. Okay. When we take the cube root, 6.022 to 10 to the power number of moles. Okay. Now, this will give you the answer as it is written here. It is equal to, on calculating I will get it as 0.0031. I haven't included 10 to the power 23. When it goes to the numerator, it becomes 10 to the power minus 23 whole raised to 1 by 3, or you can say it as cube root of that, which gives you 3.1414 into 10 to the power minus 9 decimeters. This is decimeter cube, and of that we will have it as decimeter cube root. So, it becomes decimeter itself. Okay. So, that is about the molecular diameter. Just knowing the value of B, which is a van der Waals constant, which gives us an idea about the size of the molecule, you can find out the molecular diameter, and radius will be naturally half of that. If you have to find out, we have asked to find the radius, you take the half of this value, which will give you the radius of this molecule. So, getting the van der Waals constant B or co-volume, from which we can derive at the molecular diameter, which gives us an idea about the size of the molecule. Now, to conclude, we have been seeing in this session the excluded volume of molecules in a gas, that is the volume of the molecules. It is also known as a co-volume when it is for 1 mole. The excluded volume or co-volume for one molecule has been found to be 4 into volume of a single molecule, and if it is for 1 mole, the only difference is 4 into Vm into Avogadro number n naught, which we have already seen the derivation. See, by taking that volume of a sphere for 1 mole, for 1 molecule, we have found it as 4 into Vm. See, actually we get it for 2 molecules, half of that gives you for a single molecule, and converting that to 1 mole will give you the co-volume, which we represent it as B in the van der Waals equation. And after that, from this we have found out the equation for a single molecule from this term, that is Vm is equal to B by 4 N0, and we have found for a single molecule in another way, that is considering the molecule to be sphere and taking the diameter, which was a collision diameter, we will consider that as a diameter of the molecule as sigma molecular diameter, and replacing it for radius. From that we got another expression for a single molecule, volume of a single molecule, equating these two. Finally, we reach at the molecular diameter sigma which is equal to 3b by 2n n naught whole raised to 1 by 3. That is what we got here, and a problem based on that, and with that we conclude this session. Thank you.